Hi there! In this video, we're going to talk about simplifying a ratio of polynomials. So what does that even mean? Basically, it means we're going to be reducing the big fraction with variables in it. So here's kind of the steps. They're kind of some generic steps, but they're the steps that you want to go in order on how to simplify completely a fraction with variables in it, a big one with variable expressions, which basically means like x squareds and x's combined together, added, subtracted, divided by something else that's in similar of nature. So the first thing that you want to do is find the GCF, if you remember, stands for greatest common factor. Then you want to factor completely. This is probably the hard step right here because you have a lot of different choices for factoring. You have your regular factoring where your coefficient is 1. You have of a quadratic, which means like if you had like x squared plus 5x plus 4, where there's no number in the front. Then you have your quadratics that have a variable, like a constant in the front. So instead of just a 1, it's going to have a number. That makes it a little bit more tricky. You have something that you could use the difference of squares. You have perfect square trinomials. You have just factoring out a GCF. There's a lot of different types of factoring. It can get more complicated into factoring the sum and the difference of cubes. We're going to stay away from that in this particular video, but that's also another type of factoring that you would be expected to know how to do. Okay, then the next step, this is like the quote fun step right here, is you get to cancel the like groups. Something that you have to remember about canceling is that you can only cancel I put this like groups here in quotes because you can only cancel things that are multiplied together. So for example, if I give you x plus 4 and x plus 3, you have to imagine that x plus 4 and x plus 3 are groups, okay? They're coming together. You cannot cancel things that are just added. So this is illegal. You cannot do that. You can only cancel things. I'll write it up here. If I had x minus 2, times x plus 3, and on the bottom I had x minus 2 and x plus 1. So here, these are both x minus 2, and they're multiplied by these other groups right here, x plus 3 and x plus 1. So I can cancel these x minus 2's, leaving this with my final answer. But no illegal canceling of things that you're just adding. That will get it wrong every single time. Okay, so we cancel our like groups. Our things that are multiplied together are the things that we can cancel, or we can reduce the fraction. And then the last part is to simplify the coefficients. That means sometimes you're going to have a number out front in this area, and you want to reduce that fraction as much as possible. So I have 4 different examples that kind of touch a little bit on different kinds of factoring that you can see throughout. It doesn't do sum and difference of cubes, but it does kind of touch on everything else. Oh, no perfect square trinomials. I didn't do that one. Okay, so simplify. First thing we're going to look for is a GCF, greatest common factor. So we're going to find the greatest common factor in the numerator, or the top first. So greatest common factor means what number and or letter or both do both of these have in common? What's the biggest one that I could divide out by? So I see that both of them have a v, okay? And both of them also, the biggest number that goes into 12 and 18 is 6. So I can say I'm going to take out a 6 and a v from the top. So this is like your backwards distributive property. So you're asking yourself, 6v times how much is equal to 12v? So 6 times 2 is 12, and v times v is v squared. Okay? Then you're going to ask yourself, if I take out a 6v from the second term here, 6v times how much is 18v? Well, 6 times 3 is 18, and v, if I multiply then their v times nothing is just v. So this simplifies to 2v minus 3 inside the parentheses. So if you can check it, if you were to do the distributive property, would you end up back this way? 6v times 2v is 12v squared, and 6v times 3 is 18v, and there's a subtraction in the middle. Great. Okay. I'm going to do the same thing in the denominator. What can I factor out of the denominator? Well, let's see. What's the biggest number that goes into both 6 and 30? That would be 6 again. And both of these have a v in common, so I can also take out a 6v here. Now what am I left with? 6v times how much is 6v squared? V. And 6v times how much is negative 30v? Well, that would be negative 5. Okay, now I factored out my GCF. These I cannot factor anymore. They are already completely factored, so if you go back to your list. Okay, I cancel my like groups. So my like groups, so here, this is where I want you to imagine your groups. This is a group, this is a group, this is a group, and this is a group. So do I have any groups that are exactly the same? I sure do, these 6 V's. These can cancel out. So what are you left with? You're left with 2v minus 3 over v minus 5. This is your final answer. You cannot cancel out the v's. That is illegal. Remember, you can only cancel out things that are multiplied together. Okay, next one. 5v squared plus 45v plus 100 divided by v squared plus 6v plus 8. Okay, first thing here, we're going to start on the top of our list. Says find a GCF. So I'm going to start at the top and find my greatest common factor. Do I have one? Is there something that goes into 5v squared, 45v, and 100? Yes, a 5 goes into everything. So I'm going to come down here and I'm going to say, I'm going to write a 5. Okay, so 5 times how much is 5v squared? V squared. 5 times how much is 45v? 9v. And 5 times how much is 100? 20. Okay, do I have any GCFs in the bottom? Is there any number that have, or letter that they have in common? This one has a 1, a 6, and an 8. There's nothing that can go into that besides 1, which doesn't help me reduce anything or get out of GCF. And not all of them have V's. So this stays the same. Okay, so far I'm here. V squared plus 6v plus 8. Okay, next step, factor completely. So when I'm looking at factoring, I want to look at in the numerator, I'm going to look at factoring this because I already took out my 5. So you have to ask yourself when you're factoring and the number in front is 1 here, what numbers multiply to 20 but add to 9? Okay, so numbers that multiply to 20, if you're not really good at this, I suggest writing them down. So we got 1 and 20, 2 and 10, 4 and 5. Okay, what numbers that multiply to 20 add to 9? Remember, it could also be negative 1 and negative 20, negative 2 and negative 10, and negative 4 and negative 5. What multiply to 20 and add to positive 9? These guys. So my factors are going to be on the top, v plus 4. Sorry, that's a funny looking 4. And v plus 5. Okay? In the bottom, I want to know what multiplies to 8 that adds to 6. So I want to multiply to 8 and add to 6. So what multiplies to 8? We have 1 and 8 and 2 and 4, or negative 1, negative 8, negative 2, and negative 4. And I want to add a positive 6. These guys do. So this would factor into v plus 2 times v plus 4. Okay. I want to cancel all my like groups. Remember, we can only cancel groups that multiply. On the top, I have 3 groups. I have 1, 2, 3. And on the bottom, I have 2 groups, this one and this one. Do I have any groups the same on the top or the bottom? I sure do. This v plus 4. That can go away. All right? And then I want to look out in front here, and do I have any coefficients that I can reduce completely? I have a 5, and remember right here is a 1, so I can't really reduce that anymore. So my final answer is going to be 5 times v plus 5, all divided by v plus 2. And you can leave it written this way as your final answer. Okay, next. 25u squared minus 4 divided by 5u squared plus 3u minus 2. Okay, the top immediately tells me difference of squares. I know that because 25u squared is a perfect square, 4 is a perfect square, and they're separated by a subtraction. So I basically am taking the square root of each one of these. So the square root of 25u squared is going to give me 5u and the square root of 4 is going to give me 2. So when I write difference of squares, my numbers are the same. One is a plus, one is a minus. So there's my top part that's factored. Okay, to factor this bottom part right here, this is a little different because I have a leading coefficient of 5. So what you want to do is you want to take the 5 and the negative 2, we're going to multiply them together. So this multiplies. I want to know what numbers multiply to negative 10, but I want to add to 3, the number in the middle. Okay, so what multiplies to negative 10? So that would be 5 and negative 2, or negative 2 and 5, 1 and negative 10, or negative 1 and positive 10. But I want to add to positive 3, that's going to be these guys. So, to factor, I'm going to do this. I'm going to move this down here and give me room to factor. And let me move it up a little bit more. So I have space to finalize stuff. Okay, so negative 2 and 5. So I'm going to write this out like this. I have a 5u squared plus 5u minus 2u minus 2. Then you have to do factor by grouping. So I want to factor this, make 2 groups. In this first group, I'm going to zoom this way in. In this first group, we're looking for my GCF. What does 5u squared and 5u have in common? It has a 5u. So 5u times what is 5u squared? U. And 5u times what is 5u? 1. Okay? What does negative 2u and negative 2 have in common? Remember, when this first part of the group has a negative sign, you want to factor out the negative. So these both have in common a negative 2. Negative 2 times how much is negative 2u? That's u. And negative 2 times how much is negative 2? That's 1. Remember, when you're factor by grouping, these groups right here should be exactly the same. If they're not, then you did something wrong. Now my groups are exactly the same. What do both of these terms have in common? They both have my u plus 1. So if I factor out a u plus 1, u plus 1, in my first group, I'm left with the 5u, and in my second group, I'm left with a negative 2. So this bottom part factors into u plus 1 times 5u minus 2. So I'm looking here, and I want to factor my groups that are the same. So how many groups do I have? I have 2 groups on the top, this one, and 2 groups on the bottom, this one and this one. Are any of my groups the same? Yes, 5u minus 2. So your final answer would be 5u plus 2 divided by u plus 1. Okay, last one. This one, I think these ones are kind of easy, or the easier of the ones, because it's already factored for me into groups. So now I just have to get rid of things that are the same and reduce my fraction. So you'll see right here, you already have your GCF factored out. You'll see you already have your groups here on the top, but these ones have exponents. So we just have to cancel out the exponents that are the same. So the way that I like to think about it is we'll first do our groups. So I'm going to look at 3x minus 2. I have 2 groups of that on the top and 1 group of that on the bottom. So if I cancel the number of groups that are the same, this is going to go away, and this number is going to become a 1. So there will just be one of those left. So I'm going to cancel out my exponent. And if that makes sense, I'm going to rewrite it just so you can see just this part. 3x minus 2 squared means 3x minus 2 times 3x minus 2. And on the bottom, I had 3x minus 2. So together, one of those cancels, and then I'm left with 1 on the top, which is how I wrote it here. And I cross this one off. Okay, for the x minus 4s, I have 3 of them on the top, but I have 4 of them on the bottom. So that means I can cancel out 3 of them. So this is actually going to go away. Here, I'll do it in a darker color. And I'm going to be left with 1 of them in the bottom. So this is gone, and you have to remember this is gone. Okay. Now, the last thing I'm going to look at here is my coefficients down in front. And I'm going to ask myself, I need to reduce the fraction. What's the biggest number that goes into 20 and 32? Probably 4. So I'm going to divide. 20 divided by 4 is going to give me 5. And 32 divided by 4 is going to give me 8. So now you look at, what do I have not crossed off? Okay, on the top I have an 8. And I have one group of 3x minus 2 left, and all of my x minus 4s went away. On the bottom I have a 5. I have one group of x minus 4 left, and all my 3x minus 2s went away. So this would be my final answer. So just remember, when you're going through these, find the GCF, factor out completely, cancel out things, your like groups that are the same. Remember, only by things, groups are things that are multiplied together, and then reduce your coefficients out in front, and you will be all on your way to simplifying big, huge polynomials written as giant fractions. Let me know if you have any other questions. Good luck.